Okay, welcome to another video. This one is going to be discussing a subnetting workbook that was created by Rob Jones. He's another community college professor, and he provided this IP addressing and subnetting workbook for free. So I'm going to show you a little bit about this. There are maybe two versions of this. There's a 1.0 version, and this is the latest one, and it covers most of the subnetting information you need. The very first page that you get will talk about IP address class space, private address space, and the subnet masks. So let me go ahead and speak a little bit about this. In this video, in Classful Addressing, a long time ago there were just blocks of IP addressing that were assigned by ISP providers. You would purchase that from a net provider. And the blocks of classes were A, B, C, D, and E. Now E we don't recognize. We don't use it for anything. Class D is used for multicasting, very specific reasons when we would use a Class D address. But A, B, and C were the blocks of IP addressing that were assigned. And A and B were designated for businesses, large organizations. Class C were for small businesses or small organizations. Now, the approach to this is the computer sees everything in binary, but we needed to show things in decimal so humans could readily understand what the IP address was instead of having to convert it from binary. So in a Class A, you have a network range from 1 to 127. So any network that had a 1 to 127 is considered a Class A. And that's in the first octet that you're looking at these ranges. 127 is eliminated because we reserved it for loopback testing. If you've ever pinged yourself or your computer at 127.0.0.1, that's the loopback internal testing address. And you're basically pinging your NIC. And if it replies back and says, hey, everything's okay, you're fine with your NIC. If it doesn't reply, then you know you have a problem, at least starting with your network interface card on your computer. Class B range is 128 to 191. Class C is 192 to 223. So now you know we have designated classes for each one of these ranges. Now there's a term called a leading bit pattern. If we convert this range into binary, the first leading bit the first bit will be a 0 for a Class A. Okay. The leading bit pattern for a Class B is 10, and I'll explain what these mean a little bit later when I create a chart. And the leading bit pattern for a Class C will always be 110. So every network that's Class A, B, or C is going to start with a certain pattern, and this is the leading bit pattern for each one of those. Now there is private address space. It's a different internally. It's never routed. If you have to route something from your private address space internal organization, you need a router that has NAT programmed so that it can translate your private address space to a public IP. Now the default subnet masks always follow the network. So you know when you have an IP address like 192.168.10.15, you'll have a subnet mask associated with it. If it's by default, meaning it's a Class C by default, if I have a 192, it's a Class C. My default subnet mask for all Class Cs will be 255.255.255.0. You can also use a prefix notation of /24 to designate this. People often ask me, what does the /24 mean? If I turn all of this into binary and count up all the ones in each octet, it turns out to be 24. So this is the same thing as saying /24. Now, 255.255.0.0 is the subnet mask for all Class Bs, so anything in this range right here, right? And Class As are 255.0.0.0. What this means is the network portion is the 255s. The 0 portion is the host. So in a Class A, I have the first octet designated for the network. The last 3 octets are all host, and they sort of show this to you right here. So an IPv4 address has 32 bits. And depending on the class and the subnet mask, it tells you which portion is network. Easy for humans to see, but the computer uses binary and adds out the network. Alright, so that's a great introduction into classful addressing. Later on, we'll talk a little bit about variable length subnet masking, but first we have to get through subnetting. Alright, this is it for the video. Thank you for watching, and I'll set up our next video about binary to decimal conversion.